Alright, so I'm back. What I've done is I've gone and transposed our efforts to the other side of the machine. So we're looking at the left side of the bike here, and we can see I moved my servo gearbox over here so that we now have one on the left and one on the right. And if we take a forward angle like this and we steer the bike, we can see that one moves forward, one moves back, and we get our servo linkage working. So I thought a servo would be a good choice because they're positional in nature. For you tell a servo to go to a position and it actually tries to get there, and it'll force itself to stay there even if there's forces being put on it. So I'm not an engineer. I wanted to be an engineer when I was a kid, but I'm not sure if this would work. I think it would work, but either way, let's do what's more fun than engineering this. Let's make it look cool. So the first thing we want to deal with is this arm, and the arm is going to have two ball joints at the ends. So let's start with the ball and then we'll move on from there. The ball needs to be at the exact position of this target object that we have. The right steering push rod needs a ball at its exact location, as does the, as does the target object that lives in each servo. So the easiest way to do this is to create a sort of a ball joint and make it a child of the target. Start with a sphere. A sphere is going to be particularly good for this. I've created a ball joint using a sphere before. It's really easy. And we can transfer it to target right. Okay. So we have a ball there. I'm going to do as I always do, and I'm going to group it so that we have an object we can work with that is not the actual geometry. And we're going to call this ball end. The ball end object, we can now create an instance of it. We have ball end instance, and we can move it over to this object here, which I believe is the right steering push rod. Yes. So this ball end unfortunately cannot be a child of the right steering push rod, but it can live at the same location, which is in the front end. Now we have these two balls, and we can go to the original. Where did I put that? There we go. You can go to the original and scale it down to the size we think it should be. I'm thinking no bigger than that. About 1 inch radius. And again, we're going to work with low resolution geometry because I find it easier sometimes. So we're going to make this sphere have 12 segments. So this is where our ball will be. If we make this sphere editable, we can switch to polygon mode, select the base, and extrude it. The extrude command is in here somewhere. There it is. I just use the keyboard shortcut D. Now because these are not all flat, when we extrude, wow, what happened there? Right. When we extrude, they're going to go off at a strange angle. That's not what we want. So to get around that, we can either flatten it now or flatten it after extruding. But if we flatten it now, we can actually change the shape of the sphere. So the easiest way is actually, if you have R13, so hold the control key and drag, and that actually lets you pull it out straight. The other way, if you don't have R13, is to set the offset of the extrude to 0. You can still apply the extrude. New geometry has been created, and you can just drag it away. Once you've dragged it away a little bit, you can switch to the scale tool and scale it down to 0. And at that point, I'm just going to extrude one more time. So this is starting to look a little bit more like a ball end. The important thing is that the pivot is still at the center of the sphere, and that's exactly what we want. Now we can rotate the sphere independently of our ball end, which is the cool part of parenting the geometry like I did. So we need to move it out a little bit. It's a little too close to the servo arm, so I'm going to select the ball end object and move it, but we want this end of the push rod to come with it. So I believe that end of the push rod is the target. So this ball end can actually live as a child of the target, and we can just move the target like that. So at this point we're kind of moving all of our mechanism at once. And we can just hook it up like that. So we have a big ball connector there. And we have a ball connector here as well because it's an instance. It's already done. Nothing to do there except position it. So we have a ball end instance right here. And if I switch to my orthographic view, you can see it has some strange rotation on it. And that can happen because we transferred it to an object that was rotated. So there's no harm in just zeroing its rotation and then rotating it 180 degrees so it's nice and perpendicular like we like it. So we have this ball end and the other ball end. That's a step in the right direction. The next thing we'll need is a mechanism that fits around the ball. And again, I'm interpreting this from my RC helicopter knowledge. So if some of this stuff looks miniature, it's because that's just what I'm used to. I'm looking forward to feedback on this project. I'm sure I'm going to get a lot of hobbyists and engineers telling me all the things I'm doing wrong, and I welcome that. I love accuracy, but I also like getting things done. And sometimes accuracy can get in the way of getting things done. And because I'm coming from my helicopter world, my RC helicopter world, I am also going to edit this ball end so that the shaft pokes out the other side, because that way we know it's there. We can put a retaining washer or some sort of a clamp on it. But for now it's fine like that. And again, the cool part is if I don't think this is big enough, because of the way I've built it, I can just scale it up and it all works. And we can transfer it to the other side when we're done. I didn't think I'd get into rigging in these videos, but here I am. So now we need to add these two clamps. I guess it would be sockets if it's a ball and socket setup. I'm sure there's a more official name for these. But let's start with a cube. I like a cube as a starter object. You can do a lot of different things with a cube. So I'm just scaling it down. I'm going to hit the minus sign. That's my keyboard shortcut for transfer. And I'm going to transfer it to this cylinder. First thing you'll notice is that it's at a strange angle. And that's because the cylinder is actually flipping along its axis. We can fix that, but let's just keep going until that becomes a problem. So our cube is going to be at the end of this. And we need it to fit around the ball, even though the orientation is wrong. I promise we'll deal with that. So let's bring a cylinder into the mix. So I'm going to convert this cube to an editable object and just move it away a little bit. Then I'm going to create a cylinder, scale it down, and transfer it to the cube's position. Change the cylinder's orientation so that it matches our purpose. 12 segments should be fine. And we can move this so that it fits snugly around the ball. The cool part about doing this in a program like Cinema 4D, i.e. not an engineering program, is I can just sort of go with it and design it. I don't really have to care about how it looks or how it works. Sorry, I don't have to care about how it works in real life. As long as it looks okay, we can work with that. So this is sort of what I want that piece to look like. And I can convert it to an editable object, select all the points, optimize it. Any Cinema 4D users will know what I mean by when I say optimize it. And then I can move this a little bit closer. What I want to do now is merge these two objects into one. So the easiest way I think to do that in this case is to just make them into one object using the connect function. So we just select both objects, we say connect objects and delete. We're left with one object. And then we can start to delete faces and change it. So what I want is I want those faces to basically connect to each other. I can use the bridge tool. It probably won't work very well because there's different number of faces, case in point. Or I can just delete them. I'll reconstruct it. So in edge mode, I can use the bridge tool to bridge that gap. And then up here I can bridge that gap. That leaves me with two holes. I can use the fill polygon hole. I do not know where the command is. Close polygon hole. I usually just use the keyboard shortcut. And I can close those two holes. So this is not perfect, but this works for me. We can scale this down a little bit. And scale it down on the other axis as well. And I'm envisioning this as sort of a threaded part that will actually thread onto this push rod with perhaps a lock nut. So I'm going to use the ring select tool to select ring of edges, and then I'm going to use the bevel tool. Just keeping with my low detail theme, just going to bevel it so that it's now roughly rounded. We can come in and tweak this geometry later. Now, we've created something interesting here. We can leave that geometry alone for now, sort of push it off to the side and say we'll tackle that later, or we can try to clean it up now. Since part of this screencast is all about learning, let's just clean it up right now. One way to clean this up is to say, okay, let's just go back to what we had beginning, which is a gap where two things needed to connect to each other, and try to recreate it. Or we can say, okay, let's take what we have right now and clean it up. Let's clean it up. So if I select my live select tool, I'm going to select all the polygons that feel like they should be facing me. And then just use the keyboard shortcut U-Z to get rid of all the edges. And do the same thing on the opposite side. Notice what I'm trying to do is preserve the cylinder because we're going to use that geometry later on. Then I'm going to press U-Z again. Now we have something that looks a little less daunting because these are just n-gons at this point. Now we have these triangles. We would like to keep this surface planar, but these triangles are kind of strange as a transition point. So what I'll try doing is selecting these two edges here, top and bottom, and just moving them forward. That actually looks pretty good. I just need to scale them down a little bit. I actually like how that looks. The responsible thing to do at this point would be to triangulate these or quadrangulate these n-gons so that they're good geometry. So we can select these two edges and the corresponding edges on the other side, melt them, UZ, and then we can use our knife tool in line mode, visible elements only, and we can start to say, okay, how would this triangulate? We're going to have some triangles, so that's okay. I don't mind if we have triangles for this model. That's better. We can do the same thing here. What we're trying to avoid is these concave polygons like that. That just looks horrible. So what we can do is connect, draw an edge along the line that we want it to flow, and it flows a lot better. Because we've added this extra geometry, I can select these edges that I manipulated earlier, and now they're kind of sticking out, and I can scale them down so that they don't stick out anymore. They sort of flow a little bit better. And that is starting to look like the component I envisioned. Sort of a socket at the end. I'm going to adjust the Phong shading on this so that we don't get that strange look. You know what? I'm gonna turn Phong smoothing off of this object. Actually, what if I didn't? What if I changed it to like 20 degrees? Let's increase it a little bit. 28 degrees. Actually looks pretty good. Yeah, it looks really nice. Oh, got faceting here. So there we go. 33 degrees seems to do the trick. That looks good for now. This cylinder is now what I would like to call, I don't know, socket. Let's call it socket for now. I'm not really sure what to call it. We can then instance it. Good old instance. But let's group it, because we know I like to do that. Now we can instance our group, move it down here, and rotate it 180 degrees, and position it over this ball. Now we're starting to see the problem that I mentioned we're going to have earlier, which is that these are at the wrong angle. Now we could just rotate them so that they're not at the wrong angle, but if they're connected to this system, then we have a bigger problem on our hands, because this could rotate in the future. When I say rotate, I mean like this. It could rotate in the future, and that would be a problem for us as well. So these objects should both be children of the cylinder on the right side. Wrong cylinder. I'm not naming my objects like I should. Right steering pushrod. Cylinder. So if the cylinder rotates, these go with it. That's not good. Now the pushrod is really what we're afraid of rotating, because even though it has a target expression on it, it can still rotate. I can't rotate it on these axes, but it will still rotate along the banking axis, the blue axis. So the way to fix that is to create a up vector. So currently the blue axis is pointing to the target object down here. The green axis does whatever it wants. We can tell the green axis to point to a different object. Easiest way to do that is to figure out, okay, so right steering pushrod. This point in space is where it is. So all we need to do is create another point in space above it and tell the green axis to always point there. So we can create a null object, and it's right here, but we can transfer it to the right steering pushrod location. So now it's here. And let's zero its rotation out. Move to the side view. Rotate it so it's in line with the fork. And then move it up. So the idea is that we want this pushrod to always face the sky, or to face outwards. So I can cut and in the steering group, right next to the right steering pushrod location, I can paste it. So this is the target expression. It's looking that way along the blue, but we can say your up vector is along the green. So now, as we move the steering, I'm going to lock this attribute so I can select the right steering pushrod that has the target expression. We can see that it's always going to point along the green, which is what we want. It's never going to rotate. And it also prevents it from flipping around halfway through the animation. Now that we know this null object won't rotate, we can safely rotate its children into whatever orientation we want. So in this case, we can rotate this pushrod so that it's in a more reasonable position, like I just did. And now we're starting to see the steering for our system evolve. It now looks like a nice beefy linkage. And it looks like this is a little problematic right here. I knew we'd have some stuff like that to deal with. So if we go to our range mapper, we probably just need to tweak the values a little bit. So if I select my range mapper and I look at my upper value, lower, upper, I can change it to 46, 47. I hope this works. And then this value, I'm sure there's a formula for this. There's an engineering student staring at the screen saying, "No, you just need to multiply the tangent by the sine, and it'll just figure it out." But unfortunately, I'm not that clever, so I don't know. And it looks like we're dealing with some extreme angles right here, so maybe we would want to change the way that ball is oriented. And one thing I do notice is that this is not a linear movement. Notice how it sort of races ahead of itself? The nice part is we can address that with the range mapper. We just find the spot, and again, this is amateur hour. This is just me figuring stuff out. We can find the spot where that happens, go to the range mapper, and we can actually control it using a spline. So we can control click to create points, and we can create a curve. By default, the curve would be linear, but we can introduce points at different parts of the curve like this, and we can make it race ahead or stay behind. So that'll work itself out as I tweak it some more. That looks pretty good. The only thing I need to tweak now is this. This angle is a little too extreme. It's sort of kinking on itself there. How we can fix that is that we can take the origin of the right steering pushrod, which contains the target object, and we move it forward. So it needs to be here. You can tell I'm probably going to have to rebuild this when I'm done. Let's try something different. What if we adjusted this ball end instead, so that it was more like that? That works for me. So that range of motion looks a little bit better. And this servo arm is starting to look nice and beefy like we want it to look. You can probably cut some holes in it, put some extra cylinders there. And I will have to apply this to the other side of the bike. This cylinder still has its correct pivot point, so if we wanted to add a shaft, we could create another cylinder, scale it down, transfer it to this object, cut, paste, and make it a child of this cylinder. Change the orientation, 12 segments. And this could be the main pivot point coming out of the gearbox. So that's what that would look like. The gearbox is fun because one of the art styles I really like is Firefall and District 9. So District 9 is that alien movie, they had those crazy guns. And Firefall is a video game. And these two things have something in common. Let me just pull up a couple web pages and show you. Okay, so the District 9 guns have these canisters coming off of them at strange angles. It's a really cool look, and I think it's the same sort of sci-fi look that we're going to be going for on this Razorback. So that these canisters coming off at different angles, and Firefall has something similar where the armor for the different characters have these canisters coming off at different angles. Now you're probably thinking, well, there's no canisters on a servo motor, but there is a motor. So what I was thinking is that just for style reasons, we can actually create the motor component of the servo and actually help it give the motorcycle some attitude. So if we were to say, okay, in the effort of saving space, what if our servo motor flared out at a bit of an angle, like that? You know, we can weld it so that the edges look really nice, and we can bring this in so it has more of a flush look. But essentially we can create the servos sort of hanging off the edge like that, and it'll give the bike a lot more attitude. This will start to look like a much beefier major component than, oh look, it's just a little servo. So this is, I think, a nice opportunity for some style. The other cool thing about putting the motor outboard like this is you can put the heavy electrical cabling required for this motor, and you have some more of this sort of cabling look. So you can have the cabling coming down and flowing up into the bike, making it look like it's got almost like arteries and different cables and wires feeding components that have been grafted onto this machine. So I think that'll be fun. We are now looking at the Razorback, or what I envision the Razorback to be. You know, this is Daniel Suarez's intellectual property when you think about it, but he's only described it to us, and I'm trying to bring it to life. So I'm going to replicate these changes on the other side of the bike, and maybe in the next video we'll look at something different, like the robotic arms that hold the swords. Until next time.